Hello everyone, I'm Mahek Panchal and in today's video I'm going to be teaching organic chemistry for ICSE class 10th and CBSE class 10 students. And organic chemistry is an essential part of the ICSE syllabus which most students tend to get afraid of, but there is nothing to be afraid of organic chemistry because once you get your bases cleared it will be very interesting for you. So without any further ado, let's get started. But if you haven't subscribed to my YouTube channel, please do so. I will be posting more ICSE related content for class 10th. So let's start. So basically, before starting organic chemistry, I just want to clear that you should know the definition of the chapter that you're reading, right? So let's just start from the very basic, that is, what is organic chemistry? So organic chemistry is a branch of chemistry that deals with the compounds of carbon, except for carbon monoxide, carbon dioxide and carbonates of metal. Now the reason why I've kept this exception is carbon monoxide, that is CO, carbon dioxide, that is CO2, and the carbonates of metals do not count as organic compounds. So if I ask you, is carbon dioxide an organic compound? Then no, the answer is no, because there are a few exceptions like carbon monoxide, carbon dioxide and the carbonates of metals. Now what do I mean by carbonates of metals? Carbonates of metals include like MgCO3, suppose Na2CO3, sorry. So it includes all these compounds which are carbonates of metals. So these are the three exceptions that do not count as organic compounds. And organic chemistry is basically a branch of chemistry that deals with the compounds of carbon. Now moving on to the characteristics of organic compound, there are basically 5 main characteristics that you need to know about, which I have written in short. So first is the organic compounds are made up of carbon and hydrogen atoms. So what is it trying to say is that the carbon atoms and the hydrogen atoms form an essential part of an organic compound. So if you have to characterize an organic compound, you can see if it has carbon and hydrogen atoms. So think of it like you're baking a cake. So what do you require in baking a cake? A simple vanilla cake is what I'm asking. So you'll say that you require flour, sugar, eggs, and then you require vanilla essence, right? But if I were to say, what do you need for making a chocolate cake? Then you'll say you need all the same things, but you need to add like cocoa powder, right? So the same thing is with the organic compounds. You need carbon and hydrogen atoms as an essential element, right? So just as in cake, you require flour and egg, which is the base for a cake. But then you can add on chocolate, you can add on strawberry flavor, you can add vanilla flavor, whatever you want to. Similarly, in organic compounds, you can add oxygen, you can add sulfur, nitrogen, all of those other elements can be added. But the essential elements of an organic compound are carbon and hydrogen. Moving on to the second characteristic, that is non-ionic in nature. Non-ionic in nature means it is covalent in nature. Non-ionic means that the atoms are not formed by transferring electrons. So ionic means that if there are two atoms, this is atom number A, this is atom number B. Now, if I were to say they are ionic in nature, then it would mean that B would donate all of its electrons to A and A would accept all of those, okay? But here it is saying that it is non-ionic in nature. Non-ionic in nature means that A and B would not transfer electrons, rather they would share the pairs of electrons between themselves. So this is what is meant by covalent bonds. So remember, organic compounds are always covalent, okay? No matter what, they are never ionic in nature, okay? So they are always covalent in nature and they form covalent bonds. Third point is most of them are insoluble in water, okay? This is very clear. There is no need to explain anything. It's just that the organic compounds do not dissolve in water, but they do dissolve in organic solvents like benzene, ether, etc. Fourth point, low melting and boiling points. Now this is a very good point which is given by a reason, okay? You need to understand why this characteristic is given. So you can see, now that we've cleared that the organic compounds are covalent in nature and they form covalent bonds, which means that they are held together by weak force of attraction, right? So they may be held by van der Waals force or hydrogen bonds. So since the van der Waals force have very less force of attraction and the molecules are very loosely attached, so less energy is required, hence low melting and boiling points are given. Okay. So you need to understand the reason behind why there is low melting and boiling point, because they are held together by very weak forces of attraction. The last point, they are highly combustible. So it is a clear simple fact that organic compounds, they are highly combustible in air, and in excess of oxygen they form water and carbon dioxide. But remember, if the air or oxygen is insufficient or is in less quantity, then instead of forming carbon dioxide, it will form carbon monoxide. So this is very important to remember. Next, moving on to the difference between organic and inorganic compounds. So now that you're clear with organic compounds, let's talk about the differences as well. So organic compound, remember it as the carbon being the main hero. So if you ever want to identify the organic compound, just make sure, except for these three, all rest having carbon as the main element are organic compounds. So carbon is the main hero. Think of it as the carbon being the main hero, whereas in organic compounds, it is not necessary that carbon is the essential element or the main hero. Next, organic compound is always non-ionic. As I said, organic compound never forms by transferring electrons, it always forms by sharing the pairs of electrons. Whereas in organic, there may be covalent bonds or ionic bonds. Organic compounds, as I said, held together by less force of attraction, so low melting and boiling point. Whereas this has high melting and boiling points in organic compounds. Okay, and organic compounds, they burn easily because they are combustible in nature. Whereas in organic compound, it is not necessary that all inorganic compounds are combustible. Some may be, some may be not. Now moving on to the next page. So by the way, I just want to let you all know that these are the handwritten notes that have been made by me. And if you want these notes, please just write in the comments, and I'll share the PDF with you. So hydrocarbons, as it is given in the name, it is a compound that is made up of hydrogen and carbon. Hydro means hydrogen, carbon means carbon. Okay, so hydrocarbons have hydrogen and carbon as the essential elements. So basically organic compounds are known as hydrocarbons. Okay, so now if we have to classify the hydrocarbons, they are of two types: aliphatic hydrocarbons and cyclic hydrocarbons. Now this is where it gets slightly complicated, but you need to keep paying attention to be able to understand all of it. So aliphatic hydrocarbons are also known as open chain. Open chain means that they do not form round or closed chain. So like here, if we see, this is a somewhat example of benzene. Okay, so this is closed chain, but this is open chain. Open chain means that it is not closed, like it is not a closed figure. And if we talk about cyclic hydrocarbons, cyclic itself indicates that it is like a wheel, it is like a cycle. Cycle means it gets closed, and cyclic and closed chain. Okay, it is also known as aromatic, but this part of hydrocarbons we're not going to really study. We're just going to study about aliphatic hydrocarbons. Okay, so just remember CC, cyclic hydrocarbons, and closed chain hydrocarbons. So this is characterized by the presence of rings of carbon atoms. So cyclic hydrocarbons, if it is asked what is the example of it, you can say benzene, because it is somewhat like this and it is in a closed chain. Okay, it is not open from any side. So I have just given a brief review about this. Now let's move on to the main part, that is aliphatic hydrocarbons. So what are aliphatic hydrocarbons? Basically, they are open chain hydrocarbons which are not forming a closed figure. Now aliphatic hydrocarbons are also classified into two types: saturated and unsaturated. So saturated includes alkanes, which are also known as paraffins. So you need to understand that there are alternative names for certain categories which you need to remember. Okay, it's not like you can remember only one name, you have to remember each and everything. So aliphatic hydrocarbons, saturated and unsaturated. Okay, saturated includes alkanes. Alkanes are also known as paraffins, and unsaturated includes alkenes and alkynes. So now you can see they all look somewhat similar, but they end in different alphabets. This is ane, alkane, this is alkene, and this is alkyne. So you can see saturated includes alkanes, but unsaturated has two types: alkenes and alkynes. If you talk about the general formula of alkane is CnH2n plus 2. Now you must be thinking, what is all of this out of a sudden? Okay, so let me just explain. General formula is a formula that is used to determine the chemical formula of their organic compound. So alkane, the general formula of alkane is CnH2n plus 2. C indicates the number of carbon atoms, H indicates the number of hydrogen atoms. Okay. So I'll just explain in a minute what exactly is general formula, but just get a review of it. So alkenes, alkene, the general formula of it is CnH2n, whereas the general formula of alkynes is CnH2n minus 2. So just remember the general formula because it is very, very important to remember it. Now if we talk about alkene and alkyne, what is exactly the difference? They all look the same, you might just say, but alkenes are characterized by a single bond. Now what do I mean by single bond? Do I mean the single bond between carbon and hydrogen, or carbon and any other atoms like oxygen? No, alkenes refers to the single bond between the two carbon atoms. So if I say this is the single bond between carbon, so this is known as alkane. Okay, so there is a single bond between two carbon atoms. So what matters the most is you have to see the bond between the carbon atoms, and that is how you determine whether the organic compound is alkane, alkene, or alkyne. Now alkene is characterized by double bond between the carbon atoms, and alkyne is characterized by triple bond. So this is characterized by single covalent bond, this is characterized by double bond, and this is characterized by triple bond. Now you might ask, why have I underlined all these? So these are all the suffix. So you might ask why I've underlined all of the end parts of this word. So this actually indicates the organic compound. So if the organic compound has an ene in the end, then it has one covalent bond between the carbon atoms. If it ends with EN-ES, then it is characterized by two bonds between the carbon atoms. And if it is ending with Y and E, then it is characterized by a triple bond. So for example, if I say methane, then you can see methane has ANE at the end. So methane is characterized by a single bond between the two carbon atoms. If I talk about alkene, like talk about ethene, okay, methane is not possible, ethene is only possible. So alkenes, the first member of alkenes group is ethene, not methane, because you require at least two carbon atoms to form a double bond. So alkene, let me give you an example of alkene, that is propene. So if I say propene and at the end you can see ENE, then you can see that this organic compound has two covalent bonds between the carbon atoms. Okay, and if I say propyne, you can see it has a triple bond in the formula. This is something to be very careful because they all might sound similar or they might sound confusing, but this is where you need to get your base cleared and you need to make sure that you do not get confused. If you feel that you have not understood this, please go back and rewatch the whole part. Then I think if you watch it at least once or twice, you can get the base very cleared. Alkane are characterized by a single covalent bond and alkanes have no unfilled valencies. Okay, always remember alkanes have filled valency. There is not even a single carbon atom that is alone. It always has filled valency. It is filled by hydrogen atoms. Next, it is having straight or branched chains. I'll explain later what is straight or branched chains. An example, propane, as I said. So now you might ask, what is a general formula? The general formula is a formula that is used to determine an organic compound and used to give it a structural formula. So if I say, for example, methane, okay, now you can see methane ends with ane. So what do you see? It is an alkane. It is a member of the alkane group. So you can see it is characterized by a single bond. So I'll write the formula CnH2n plus 2. So basically these general formulas are used to write the chemical formula of an organic compound. So CnH2n plus 2 I have written. Okay, so I'll tell you later what is actually meth, eth, prop and all of that. They are the numbers in nomenclature. So meth means 1. So you can see there is one carbon atom. So I'll write 1. And ane means it is ending in single bond. So for finding the H, we can see N means number of carbon atoms. So C 2. N means how many number of carbon atoms are there. So meth means 1. I'll explain it later. So this. So CH. So there's 1. So there's no need to write it. 2 ones are 2 plus 2. That is CH4. So this is how you find the chemical formula of an organic compound using its name. Okay. So you can see it ends with ane. So the general formula applied here is this. So if I talk about ethene now. Okay. So if I say ethene. Okay. So it ends in ene. So you can see it is alkene. So it has a double bond. So double bond means I'll take eth. Eth means 2. So what is the general formula? First of all, CnH2n. That's it. Okay. So C2 and H4. Okay. Because I've kept 2 here. So this is how you find the chemical formula by using the general formula. So you just need to memorize the general formulas and that is how you will do it. Next, there is a special group called the alkyl group. Now, alkyl means it is a group that is formed by removing one hydrogen atom from an alkane molecule. So alkane molecule, suppose there is an alkane molecule, methane. So if I remove one hydrogen atom from the methane, then it becomes methyl. So methyl, this is, you can see CH4. I removed one hydrogen atom, so it becomes CH3. Ethane has 6 hydrogen atoms. If I removed one, it becomes C2H5. You can see there is no effect on the carbon atoms. The carbon atoms remain as it is, but the hydrogen atoms get reduced by 1. The general formula of alkane is CnH2n plus 2. But as you have removed one hydrogen atoms, you can see CnH2n plus 2 minus 1. Okay, so plus 2 minus 1 equals 1. So CnH2n plus 1. So general formula of alkyl group is CnH2n plus 1. So make sure to remember the general formula of all the groups. And now talking about types of formula. So what are the types of formula? So you can see there are 3 important types of formula: molecular formula, structural formula and condensed formula. So molecular formula, it indicates the kinds and number of atoms. Molecular formula CH4. This is a molecular formula of what? Methane. So this is a molecular formula of methane. Structural formula means writing it in structures. So there is only one carbon atom and there are 4 hydrogen atoms. And you can see methane ends in ane. So there is only one single bond in carbon atom and meth means 1. So single bond H. This is a structure formula. Now what is condensed formula? Condensed formula is a type of structural formula, but condensed means narrowing it down, right? Like if I say C2H6. So now if I have to write it down, that is ethane C2H6, then C, this is the structural formula which I'm drawing. It's okay if it doesn't make sense. I'm just going to show you what the condensed formula does. Okay, so condensed formula means narrowing it down, shortening it. So we'll write C and then there are 3 H. So CH3 dash means the bond. And then there's also another carbon atom and then there's 3 hydrogen atoms. So this is CH3. This is the condensed formula of ethane and this is the structural formula. Okay, so you can see how the structural formula is very big and the condensed formula is very short. So I hope you understand in this video, and in the next video I'm going to be talking about the nomenclature and how to write the IUPAC names. So I really hope you enjoyed this video and you found it really helpful. If you did, please make sure to subscribe to my YouTube channel and share it with your friends who are also in 10th so you can help them as well. Let me know in the comments any feedback that you would like to give me, because this is my first time teaching on YouTube especially. If you want any other doubts to be solved or if you want any other chapter to get explained, then please let me know in the comments and I'll see you all in the next video. Thank you.